So let's have a look at question 7. You may have found this a challenging question, I don't know, but let's see. So a train of mass m kilograms travelling at 20 metres per second applies its brakes, causing the wheels to lock up. Whoops, need a better train system, I think. The train decelerates at a constant rate, coming to a complete stop in 30 seconds. So we need to use the Suvat equations, don't we? Use the formula for constant acceleration. Yeah, thanks for the tip. Hopefully you didn't need it. So let's just start this in, shall we? So question 7, it's travelling at 20 metres per second. Train decelerates, constant rate comes to a complete stop, so V equals 0 metres per second in 30 seconds. So that's what we have, isn't it? So what do we want to find? Acceleration. Yeah, because, well, whenever you're doing forces, you see, you've got to find the acceleration, haven't you, when you're using F equals ma. So V equals U plus AT. Let's have a look to see what's happening then. So 0 is equal to 20 plus 30. So A is equal to what, negative 20 over 30. So negative 2/3 meters per second squared. Okay. What's this acceleration? By modelling the train as a particle, find the coefficient of friction between the railway track and the wheels of the train. Okay, so what we're going to do here then? So you've got a train moving on a surface, haven't you? It's moving with acceleration negative 2/3. That's an acceleration over, means it's moving that way. You've got the normal reaction. You've got the weight there, which is going to be mg. The normal reaction is going to be the same as mg, isn't it? And what else have we got then? We've got a frictional force, which would be this way, and no other forces acting on it. Okay, no other forces acting on it. So that means that resolving horizontally, you must have negative F is equal to mass times acceleration, which is equal to negative 2/3 m, and you've got R is equal to mg. So using F equals mu r, you must have mu is equal to F over r, which is equal to 2/3 m, that's F over r, which is mg. So that must be, the m's cancel, 2/3 over g, 2 over 3g. That's it. Okay. Remember, pause the video and just have a look at it again if there's anything you want to go over again. So I'm hesitating, just a bit of a weird question, wasn't it? Okay. But hopefully you're happy with it. Okay. Just reading the question again, it doesn't say anywhere that it's travelling horizontally, does it? But it doesn't say it's travelling at an angle either. Okay, so you just got to make that assumption. Okay. Next bit, train is no longer modelled as a particle, so that the effects of air resistance can be taken into account. State the reason whether the value of the coefficient of friction calculated using this revised model will be greater than or less than the value calculated now. What coefficient of friction? That's all to do with the what's happening between the surface and the actual object, isn't it? Okay, so as long as the surface is not changing, the actual shape of the object shouldn't make any difference whatsoever. Okay, so wind resistance and so on will change, yeah, but no, the actual friction, no, it's not going to change at all. So I would say it remains unchanged because the air resistance does not affect the surface at all. Okay, so the coefficient of friction will be the same. Well, hope you found that helpful. Okay, and off you go with the rest of your questions.